Hello, we are discussing about GATE 2012 ECE paper. The average power delivered to an impedance 4 minus J3 ohms by a current 5 cos 100 pi t plus 100 amperes. So there is a current source and the current source is given, which I am saying it as I itself, and next it is connected with a resistance, that is impedance, not resistance, impedance. Z is equal to 4 minus J3 ohms. Okay, so how much power is delivered to this impedance by this current source? Okay, and options are given 4. We have to choose the right one. So in practice there are 3 different types of powers that we know it from the power triangle. Power triangle says this is a power triangle, okay, whereas it is indicating it as theta and hypotenuse is S, opposite side is Q, and this is P, okay, adjacent is P. So S implies complex power or apparent power. S is called as apparent power, or it is also called as complex power, and S can be written as P plus JQ, okay, and P is equal to real or average, okay, real or average or true power or effective power. These are all other names for this P: real power, average power, true power or effective power, okay, and this will be measured units for P. Units of P is equal to watts, whereas units of S is kVA, or here it is kilowatts, kVA kilowatts, and Q is reactive power, and this reactive power can be either QC, that is capacitive reactive power, or inductive reactive power. Both will be measured, okay, both will be measured in units. For this one, units of Q is kVAR, okay, kilovolt ampere reactance. So there are 3 different types of powers, S, P and Q, and 3 are going to be having different units: kVA, kW and kVAR. And here average power, that means power delivered to resistance itself. True power is power delivered to resistance itself. P is I square into R, whereas Q can be calculated as QL is I square XL, and QC I square XC, whereas S is equal to P plus JQ. So here now from the question we can identify in 2 ways, okay. From this average power we can say the asking is about P. Otherwise, by looking at the notations also, A, B, C, D all are in watts. Watts are going to be units for the real power. So simply you are going to calculate P, power delivered to resistance, okay, power delivered to resistance part of given impedance. So here we are only going to calculate P value, which is nothing but I square into R. It is not Z. R is nothing but Z is equal to R plus JX. So R value from this one we can identify it as 4, and P is equal to I square R. I value is 5, and this is 5 cos omega t, which is nothing but maximum value. I maximum cos something you are writing. So this is peak value, I peak or I maximum, which is 5. But we require always these are going to be related to the RMS values. All these are related to RMS values. Effective values or AC values. Okay, RMS or AC values. So I RMS square we must consider. IRMS is equal to I maximum by root 2 for a pure sine wave, square into R. So P is equal to Im is phi, maximum value of current, by root 2 whole square into 4. So phi square is 25 divided by 2 into 4. 25 into 4 is 100. 100 by 2. So power is equal to 50 watts. Power is 50 watts. So the right answer for this one is B. Remember that one, all these powers what we specified S, P and Q, all must be related to the RMS values only. Okay, because we are dealing with AC quantities, and AC quantity is nothing but RMS value only. Okay, thank you.